the grid appear. Draft your first line here. Design a new world. Watch your vision unfold.
Hello guys, and welcome to today's lesson on conventional representations. So today we are looking at conventional representations in engineering drawing. Now conventional representations are just like for how do I call it, for let's say a secretary, what shorthand is to a secretary. It's the same thing that the same way, or in the same way, conventional representations are to an engineer or a detail engineer or a design engineer. Now, conventional representations are a way in which we represent some common features in a simple way. Because usually when it comes to drawing, especially when you are drawing on paper or on board, and you want to actually do everything right to the bone or right to the detail, it takes so much time. And so for us to be able to save some of the time, what we do is that we use the conventional method to simplify some of the representations so that it will be easier for us to draw and it will save us much time. So looking at it just from this statement, it says there are many common engineering features which it is difficult and tedious to draw in full. In order to save drafting time and space, in order to save drafting time and space on drawings, these features are represented in a conventional form as shown. So let's just roll back straight to this page or this slide. And these are some of the conventional features that we have. As per default, these are the conventional features that we have. So we have features like internal and external thread. And for internal thread, you see this member, the inside threaded part is what we call the internal thread. And for a screw or even for a shaft where you have this um, pattern or cut pattern, that is what we determine or we say it's an external thread. So this is an external thread, this is an internal thread. We have shafts, we have step shafts. A step shaft is a shaft that has different cross sections, either or in diameter or size or shape. Then we also have here the spline shaft and then the serrated shaft. And then we have a knoll, and then we also have holes around the circular pitch and then bearings. Now I know some of you may not be used to these parts. That is why I'm showing you their images so that you see how they look like. Then as we head on to how we can represent those features, it becomes quite easy for you to follow. So let's head on to this slide where we have the list of features and how we can be able to represent them conventionally. So for the first one, we have external screw threads. And for external screw threads, this is how it looks like in 3D. This one is what we call a stud. Okay, STUD, stud. Now the stud is usually represented. Um, the way it's an external thread. Okay, it has an external thread, and since it has an external thread, we represent it by showing the external thread. Now, instead of us drawing these lines on it, we just represent it with these two lines. One is thick and one is thin. The outer line is thick, the inner line is thin. And that is how we represent it. So if we are looking at it in this view, if we are looking at it in this view, then we are looking at a stud like that. Let me reduce my size a bit. So that is a stud, and if we represent it in this view and we draw it, that is how we are going to visualize the stud. Now, when we cut the stud into two, if we cut it into two and we take one side off, this is what we are going to see. That is for the second image. That is when we cut the stud into two. Now, this is representing a sectional drawing. As you can see, part of it is hatched. So they are showing it in section. We'll look at sectional drawings later. But this represents when this is cut, and this represents when it is not cut, the full side. So as you can see, the outer line is thick and then the inner line is thin. Okay. Now, when we are showing it at the end view, we have a thick outer line and a thin, incomplete circle. Sorry, a thick outer circle, a thick outer circle, and a thin, incomplete circle. That is how we present it from the end view. That is, if you are looking at it in this direction, the end view of it, that is how it will be represented. So that is how we represent external threads. Or yeah. Now, a minute. Let me see if I can figure out. Okay, yeah, it's deleted. So the next one is an internal thread. So as we looked on earlier on, an internal thread is a thread which is inside the object. Now this is a block, and the block has a thread, and this is to fit right into this internal thread. This external thread is to fit right into the internal thread. The block has been cut into two to expose this thread. And since the block has been cut into two to expose this thread, we are looking at this. If you watch this in this view, if you are looking at it in this view, this is what you are seeing. You have the block, which has been cut into two, so it has been sectioned. And then we also have the thread feature inside the thread feature. Now you realize that this one has the outer line, which is this one to be thin, and the inner line to be thick. Thin outer line, thick inner line, and that is how we represent an internal thread. Then when you look at the end view, if you look at it from the end, you are seeing an outer incomplete thin circle, okay, an outer incomplete thin circle, and an inner complete thick circle. And then when you look at this, this is if you have the block in full and you are looking at the thread and it is a hidden feature, then you would have this hidden detail. So that is how we represent an internal thread. Then let's head on to screw the two together. That is when you have your block and you are inserting your stud. Now, there is a rule in the situation whereby you have two threads. That is, when you have an internal thread and you have an external thread, and you are fitting the external thread into the internal thread. In this situation, you have the block and you are fitting the stud into the block. Now you realize that this is a situation whereby you have two threads coming together. And since you have two threads coming together, there is a rule which guides the situation whereby we have two threads coming together. Now, the rule simply states that when you have two threads together, an internal and an external thread, we consider the internal thread let me um okay, we consider the internal thread as female and the external thread as male. So when we put the two together, the external thread is what is shown, right? The external thread is what is shown. So when you look at this part, you realize that here we have this stud going into this block, this internally threaded block, and you have the stud moving in partially. It hasn't completely entered into the thread or the hole, but the partial part which is inserted, you see that it has an external thick line and an internal thin line, and that is how we represent an external thread. Then from where it ends, you are now going to see an external thin line and an internal thick line. So because the external thread is not going all through, where it ends, you can now see the external thread, the internal thread of the block. Now, if we are looking at this in the view, if we are looking at this in this direction, if we are looking at it in this direction, then we realize that we are going to see only the external thread end view. Okay, only the external thread end view and not the internal thread end view. This is the representation if the block was complete and we have inserted the stud. Then you will see them in hidden detail like this. So that is how we represent the two joined together, the stud and then the block. Now let's look at interrupted views. Now interrupted views are views that we draw or we are required to use in situations whereby we are to show the length of an object, but the length is so much that the scale that we are using makes it impossible for us to see the details on the drawing. What do I mean by that? Now, let's see, or let's consider that we are drawing an electric pole, right? So this is our electric pole, and you and I know that for an electric pole can be about 7 meters high, and we only have where we are going to connect our lines, the details here, and then of course the base. There may be some details or some form of arrangements here, but we are mostly our concentration or where you see anything going on with the electric pole is the top part and then the base. Okay, the top part and then the base. Now we are to draw this electric pole, which is 7 meters. When we convert into millimeters, we are going to have 7,000 millimeters. And we are to draw all this on an A4 paper. So we have an A4 paper. A4, A3, all right, and you have a dimension of 297 millimeters by 210, if I'm not mistaken, millimeters. Now, drawing this 700 millimeters to this paper and using a scale factor, of course, will make our drawing quite small. Our drawing will be very, very small. So what can we do? We have to find a way to show our drawing so that we can show the details. So we can employ what we call an interrupted view or a broken view. So what would we do? Now, instead of us showing the whole thing like that, we can just show the first part, introduce a broken line, show the base part, let me see, right, and then we show our detail. Now this is what we call the interrupted view. Now we also do our dimension. We interrupt our dimension, and then we can also dimension our parts. 7 right. So doing this is what we say we are, it's what um we are breaking the view. Okay, that means that we have broken the view. We haven't clearly drawn something that is up to 7 meters, but we are telling you that we what we have here is 7 meters, so that we can be able to draw our detail here. And when we draw our detail here, it is something that you can be able to see. Unlike us drawing something to the true length, where we are going to have something like this. We can break the drawing and for us to be able to show the full detail of the parts. So um that is what we call the broken view. Now, there are so many ways in which we can show the broken view or interrupted view, especially for rounded solids. We can do this or this, right? Or for a rectangular part, we can do this. However, this method where you use this broken line, it can be used for whichever cross section you are referring to. So whichever cross section that needs to be broken, you can use this method. Or of course, you can decide to also use this one, right? So that is the reason why we employ broken views mostly, and how broken views look like, and the meaning or the reason why we would employ a broken view. Then let's head on to a squared end or local flat on a shaft. Now for shafts, we usually represent shafts because they are rounded objects, or they are objects with circular cross section often. We just represent shafts by drawing this and then putting a center line through, and we know we have a shaft. However, there are situations whereby the shaft could have, like we are seeing here, a rectangular cross section, and then you may even have the part of it which has been cut or flattened like this. So how do we present such a thing in conventional representation? The square cross section, we draw a cross across like this, and then for the other part we just draw the center line through and we leave it like that. So that is how we show the difference in cross section. We cross the square parts, and then we also cross the flat parts. We cross them up like that. And when we cross the flat parts or the flat surfaces, it clearly tells whoever is looking at the drawing that you are dealing with a cross section which is flat, okay, or a flat surface of an object. So that is the square end or flat, local flat on a shaft. Then let's head to the next slide. So for the next slide, we are looking at, right, so now let's look at shafts where we have a spline shaft and then we have a serrated shaft. So when we are looking at their cross sections or end views, this is how we are going to show a spline shaft or a serrated shaft. In the situation how in the situation whereby we are looking at it in this direction, then we may have something like this. Right, so let me just show a broken part. Right, and then the serrated parts start from here. So I can show two lines like this, and then at this side I can also show two lines like this. Right, so at the end view, then I can be able to draw this, and then draw my serrated part, and then add my center line, which I didn't earlier on. So this is the end view to this. So this is for a spline shaft, and of course for the serrated, you are going to have lines, and then of course the end view is going to look like this, right? So that is how we are able to show spline shaft or serrated shaft. Usually where we have the shaft connected to the motors are where we usually have this type of splines and serrations to help the motor um, not slip, or to help the shaft not slip when the motor turns them, right? So that is the spline shaft or serrated shaft. Now I am going to quickly go back and show you how we can use AutoCAD to represent these features. Since we are using AutoCAD for our drawing, we have to know how to be able to use AutoCAD to represent these. Instead of doing the sketches, I think it will be much fairer if we use AutoCAD to do this. So I am going to um, minimize this, or let me try put this to the side. Okay, and then let me open CAD. Oh, before we do, I think I have to do some cleanup. Alright, so this comes up and deletes everything on screen. Yes, and now I can close it. Right, so now I have AutoCAD on. Let me minimize AutoCAD. Move this slightly up here. Right, so let me increase this a bit. Right, okay, So first of all, what we are going to do is to go through these exercises. We are going to select the AutoCAD ISO template, which is a template for imperial drawing. Sorry, metric drawings. Template for metric drawings. So AutoCAD ISO, and then we will have to create layers, obviously. But before we do that, we are first going to click in this command line and then type ZOOM, zoom, enter, and then click on A. Click on A for all, right? Then I will go to the layer properties manager. Let me open this up so that we do that. Okay, click on the layer properties manager. If you don't have a template that you are using with your layers already there, then you would have to start up like this and create your layers, right? So we are going to create layers, and of course with previous videos you know how to create layers, and um how to create layers, and also how to set your layers current, and also what layers are. If you haven't done that, kindly refer to the previous videos on AutoCAD, and you there is a video which tells how you can what layers are, and how you can create layers, and why the layer property manager, right? So let me just click here and then rename my layers. Just going to rename them in a few. So construction line, as CONST. Then we have hidden, and then we have center, and then we have let me use a thick line, right? And then let me add a thin line just to be sure. Right, I'm not going to add the one for text and all that because I don't think I'm going to write text or anything. This is just to represent what is here. So I think just this, these layers should be enough. So let me check on the construction and then go to the line types and then create and load in my line types. First hidden, and then let me load up center line. Right, so I think we clicked on hidden. So we click on hidden, click OK. This is changed to hidden. Click on continuous here and then select center and then click OK for the center line. Right, so from there I will click on construction, set it as current, and then I can close this. So now let me minimize this as I did previously. And then let's start with that of the external thread. So for external thread, you can use the rectangle tool or the line tool. So let me, for demonstration's sake, I'm going to use 150 of length, and then I'm going to use the offset tool to offset downwards. Let's say 50. Right. Then let me close the ends here, and then the ends here. So if this is a shaft with an external thread and I'm drawing in AutoCAD, what I can do is introduce my um, center line, and then when I introduce my center line, I am just going to offset about 5 millimeters. Okay, so the offset to 5, and offset from here 5, from here 5. Then I will highlight, click on this, that is my center line. So I click on the layer property manager and then come and select center line here. Now my center line is currently being shown, and I'll highlight this too. and then thin line. Oh, let me go to the property manager and make sure. What did I do? And make sure that there is a difference between these two. So thick and thin are all having the same line width. Let me make things 0.05, and then let me make thick. Just click on OK. After you've been able to select you click on the line width. Okay, click on the line width, select the line width you want, click on OK. Then let me come to thin, line width there. Then I'll select 0.3, click OK. Now for this to be this to show visually as you are drawing, you will click on this button, which is the line width. Okay, so the line width display. So we click on the line width display, and whilst it's active, when we change the line width, we should be able to see the differences. So let me first select the internal ones, and then they are thin, of course. Then I'll select the external ones, and then I'll change the layer to thick, right? So you realize that these ones are thick, these ones are thin. So for the other part, which is for the circle, the end view of this, I'm just going to draw the lines and then one through here. Um, we offset 50, so that means that the diameter is 50. So I'll select circle diameter, come and click in the intersection here. And when you click in the intersection, just make sure that your object snap is on and it's indicating the center point. Okay, so let's type 50 because we want 50 for the diameter. All right, is it 50 or it's 50. Then we also offset another 5 because that is how we offset from here to here, 5. So undo that, 5. Right, now our circle, the thin one is incomplete, but the thick is complete. So let's highlight them and change them. Thick line. Okay, for the external one, press escape to move that, then highlight this, and then we will select thin. All right, thin line for this. So thick and then thin. Then we will click on the modify tool, right? The arrow down here. Select the brick tool and then come and click on this point. Move the cursor in this direction. Okay, I just turned off the auto mode because it is going to interfere. Right, so go a bit, then I click. So this is broken. So we have here the representation of a threaded part, an external thread, front view, then the end view. All right, front view and end view. For the internal part, it's just going to be vice versa. So I can even decide to copy the same thing. Or let me just draw that. Another line 150. Then I offset 50. Join those two sides. Draw a center line through. Then I offset 5. Right. So for the outer one, the internal threads, this is going to be, this two will be thick. So I'll come to layers, change it to thick, and then the outer ones to be thin. Right? I'm going to do the same to this. Draw a circle. Oh, first, let me change this to a center line. So let me change it to a center line. Yeah. And these ones to center lines because they are to be center lines. Great. So the outer one is a thin line. So thin. And the inner one is a thick line. Thick, 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 thick. Where is it? Where is it? So we break it. Right. Then we now um create center. Right. So we have this. So this is for an internal thread. This is for an external thread. Right. An internal thread and an external thread.
Ooh, white lines on the cool blue grid, building worlds that softly bloom. Precision is a quiet space. Welcome to the flow state room.